Water is leaking out of an inverted conical tank at a rate of 10,000 centimeters cubed per minute at the same time that water is being pumped into the tank at a constant rate. The tank has height 6 meters and the diameter at the top is 4 meters. If the water level is rising at a rate of 20 centimeters per minute, when the height of the water is 2 meters, find the rate at which water is being pumped into the tank.
So here we have our right cone tank. So water is leaking out of the tank at 10,000 centimeters cubed per minute. And we know that the water level is rising at 20 centimeters per minute, but we don't know what the rate that the water is going into the tank is. So that is going to be our Waldo. So this problem has to do with volume. So to find the current volume, we're going to take the volume coming in minus the volume coming out. So what we're trying to do here is we're trying to take the derivative with respect to time to ultimately find the rate the water is going in. So we're going to take the derivative with respect to time of the V current, and then the same for the V volume coming in and the volume coming out. So what we're going to do for our V current is we know the volume equation for a right cone, which is volume equals 1/3 pi r squared times the height. So we have two variables here, so what we need to do is solve for r so we can get both things equal to h. So this is a right cone. So what we're going to do is we're going to go over the diagram. So here we have our right cone. So we know that the radius of the cone is 2 meters because we know that the diameter is 4 meters. So we have our radius over 2 is going to equal 1. So what happens, it's the same thing for the height. Because this is 6 meters, it's the height over 6. And we can set these equal to each other because they're both equal to 1. So what happens is our radius equals 1/3 height. So now we can go back over to our equation. So we can plug our rate equals 1/3 height into our equation, which is volume equals 1/3 pi times 1/3 height squared times height. So this ultimately simplifies to volume equals pi over 27 height cubed. So to find the derivative of V current, because this is just the simplified version of our equation, we're going to take the derivative with respect to time of volume, which is dV over dt, and that simplifies over here. And we're also going to take the derivative of pi over 27 height cubed, which comes out to pi over 9 height squared times the derivative of h with respect to t. So what we're going to do here is we're going to bring this derivative over here, and that's going to be our derivative of V current with respect to time. And then we know that the derivative of the volume going out with respect to time is 10,000 centimeters cubed, because it's what the problem previously gave us. So what we're going to do is for our height, we know that at the height of 2 meters, or 200 centimeters, the water level is rising by 20 centimeters per minute. So we can plug that in for the derivative of the height with respect to time. So we're just going to plug all these things in, and then to solve for our Waldo, we're going to bring the 10,000 centimeters cubed per minute, over to the other side and solve, and here is our answer.